let's do some examples about the dot product. So we want to look at the U. We want to look at U and V here. We want to find the angle between them. So if I have U and V, recall I can use the formula that cosine of theta is U dot V over the magnitude of U times the magnitude of V. So I can use that, and I can take the arc cosine to find the angle. So U dot V is 6 minus 1, which is 5, and the magnitude of U, 9 plus 1, that's the square root of 10. The magnitude of V, 4 plus 1 is the square root of 5. So we have that cosine of theta is 5 over the square root of 50, right? So I take this number and then I take these two multiplied together to get square root of 50, which comes out to be 1 over the square root of 2. So that tells me that theta is pi over 4. So that's kind of neat. In general, you may not be able to figure that out directly. If this number isn't a standard unit circle number, you may not have that, and that's okay. So let's look at this case. Well, it's 3D, so the dot products and stuff will be a little more difficult. U dot V is going to be 6 minus 6 plus 0. I was wrong. That's 0. Well, U dot V is 0. So we know they're orthogonal. So theta has to be pi over 2. Now you could compute magnitude of U and magnitude of V, but why would you do more work than you had to? You know, that work smarter, not harder, as they say. So if you come over here now and you want to determine if vectors are orthogonal, parallel, or neither. Well, remember, just like over here, if the dot product is 0, then the vectors are orthogonal and you're done. Now, there's another way to determine they're parallel, and it uses the dot product, but it's not really any more convenient than doing it the way we've previously done it, so we're not going to use that. When I look at these two, I look at U and V, I see this negative third here. But what I notice is that this is a 1 and that's a negative 2. So that's negative 2. That's like twice the size of that one. This is a 2 and negative 4, so that's like twice the size. So I'm gonna go out on a limb and say maybe they're parallel. Let's see if we can figure that out. So in this case, I would have to multiply by 3, negative 6 to get there. So if I do negative 6 U, I get negative 6 over negative 3 I minus 2j, which is 2 times I minus 2j, which is 2I minus 4j. So they're parallel. Well, that's kind of neat. So we didn't have to work too hard. Now, if this didn't work out right, what we would do is we would take the dot product. And if that dot product was 0, we would know they're orthogonal. And if this didn't work out and the dot product wasn't 0, we just don't have any other information. We could get that angle, but it didn't ask us to. So again, why work harder than you have to, right? So looking at these, well, these have the same magnitude, but these don't. So I can pretty much rule out that they're parallel, because negative 1 times this is 2, but negative 1 times this, it'd be negative 3. It wouldn't be positive 1. So they're not parallel. So let's see if they're orthogonal. All right, so we get negative 4 plus 3 plus 1, which is 0. So it turns out they are orthogonal. Well, that's kind of neat. And if we were to draw these in space, what you would find is that even though it kind of points out of the axis in kind of an odd way, and this one points out of the origin in kind of an odd way, they would still form a right angle when you graph them. And I guess that wraps up our examples for now.